Hey guys, we're going to do a quick video lesson here on 3.2 and 3.3, proving lines are parallel using a transversal and the angle relationships. Here's kind of an agenda that we're going to set out for today, so if you missed class you kind of can see what we did in class as well as what you missed. Now just as a quick reminder, last class we talked about this method called squiggle squiggle dot, and I also have a shorter video going through that in more detail. But when we use squiggle squiggle dot, we kind of follow a pattern with these dots and squiggles, and when we look at this relationship we know that these dots are equal to dots, these squiggles are equal to squiggles, and a squiggle plus a dot adds up to 180 degrees. We know that these three relationships are true when the two lines cut by the transversal are parallel to each other. So what today's lesson is going to do is it's going to take that conditional statement that if lines are parallel, then these angle relationships are true. And what we're going to do is we're going to take the converse of that, meaning if these angle relationships are true, then I know that these two lines are parallel. So we're going to skip over the homework there real quick, and now we're going to jump to 3.2 and 3.3. And what we're going to do is we're going to quickly kind of outline our postulates and theorems for this lesson, and then we're going to go ahead and try some practice. So zooming in here on our notes, one of the first angle relationships we talked about last class was the corresponding angle postulate, which said if two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. So the first part of that hypothesis, so if you think about this back in chapter 2, we talked about conditional statements as P implies Q. So if K and J are parallel, then angle 1 is congruent to angle 2. Now when I talk about the converse postulate, that means we're going to go ahead and flip P and Q. Rather than P implies Q, now Q implies P. So if the two lines cut by a transversal have corresponding angles that are congruent, then their lines are parallel. So if angle 1 was congruent to angle 2, then we can say that line K, is parallel to line J. So corresponding angle postulate is a postulate because it is it's a definition without proof. We don't need a proof to prove or to use the corresponding angle postulate. However, the rest of our relationships all stem out of that and our vertical and linear pair definitions. So then we can use theorems because they do need proofs. So the first theorem that we're going to look at today is the alternate interior angle theorem, which states if two parallel lines are cut by a transversal, then the pair of alternate interior angles are congruent. So if K and J are parallel, then we can say angle 1 is congruent to angle 2. The converse of that, meaning we switch it, just says that if the angles are congruent, if angle 1 is congruent to angle 2, then J has to be parallel to K, or K parallel to J. Consecutive interior angle theorem states that if my two lines are parallel, then the consecutive interior angles are supplementary. And remember, supplementary was one of our key vocab words back in chapter 1 and also in chapter 3, which means that their angles add to 180 degrees. So if K and J are parallel, then angle 1 plus angle 2 add to 180 degrees. The converse means we switch it, so if the angles add to 180 degrees, then my lines, K and J, are parallel. The last relationship we're going to cover here is the alternate exterior angle theorem, which says if the two lines cut by transversal are parallel, then the angles they form at angle 1 and angle 2 have to be congruent. And the converse of that means I'm going to flip it, so if the angles of 1 and 2 are congruent and they're alternate exterior angles, then I know that line K is parallel to line J cut by the transversal. Okay? So that's just a quick outline of all of our different angle relationships. And remember, all these relationships between angle 1 and angle 2 are all defined using our squiggle squiggle dot method. So let's go ahead and jump to the second page of the notes, which means we're going to start with going ahead and make sure to read the directions carefully in this lesson. Because depending on what they're asking us to find or conclude, that depends if we're going to use the converse or the regular postulate and theorem. So state the postulate or theorem that supports each of the conclusions. So they first give me a number 1, they tell me that A and B are parallel. So if that's true, then I know A and B are parallel, which means squiggle, squiggle, dot applies. So I'm going to apply my squiggle, squiggle, my dot, and my dot to all my angles. As long as you're consistent with your pattern, it's going to work every time. So because the lines are parallel, I know the dots are equal to the dots, the squiggles are equal to the squiggles, and a dot plus a squiggle has to add up to 180. So the conclusion that they want to draw is that 2 and 7, angle 2, I'm going to use my yellow highlighter again, 2, which is a squiggle, and 7 have to be congruent. Since they're both squiggles, they should be congruent. And since I know the angle relationship of 2 and 7 are that the fact that they're inside the parallel lines and opposite sides of the transversal, inside opposite would tell me that they are alternate interior angles. So the conclusion I would make here is that the theorem that I can use is the alternate interior angle theorem. Because I started with parallel and went to the angle relationship, that means I can go ahead and just use the regular theorem. In example number 2, they tell me that angle 4 and angle 7 add to 180 degrees. So when I look at those two green boxes in terms of those two angles, one's a dot and one's a squiggle, so they have to add up to 180. Since they both add up to 180, and they're also inside my parallel lines and on the same side, inside, same side tells me consecutive interior angle. But here we have to be very careful because we're given the angle relationship and we're concluding parallel, which means we're going to have to use that converse and switch the hypothesis and conclusion. So the consecutive interior angle converse theorem. Converse theorem. And I kind of abbreviate theorem with this TH and a superscript M. If you want to write out the word theorem, you can do that as well. Alright, let's look at examples 3 and 4. Find the value of x and y. Explain your reasoning by stating the proper theorem or postulate. So this is a two-part question. They want me to find my theorem. They want me to find the values of x and y, given that the lines are parallel. And then they want me to state the theorem or postulate depending on the angle relationship between the given angle, in example 3, 130, and the unknown angle, x or y. So let's go ahead and first look at the relationship that x has with 130. Because the lines are parallel, I know squiggle, squiggle, dot works. So if I make 130 a squiggle, that means x is going to be a squiggle and y is going to be a squiggle. So what do I know about x and y? They have to be 130. Once I've identified the angle measures, I also want to go back and look at the relationship that x had with 130 and 130 had with y. So, because they were both squiggles and they were on the same side and we skipped a row or skipped an angle, we also called these corresponding angles, x and 130. So, since those angles are corresponding, then we can go ahead and use the corresponding angle postulate. If I wanted to figure out y, I would understand the relationship between the red angle and the yellow angle are outside the parallel lines and opposite sides of the transversal. Opposite outside tells me alternate exterior angle theorem. And we were given parallel, so we're always going to go ahead and just state the regular theorem. Go ahead and try example 4 on your own. You can always follow along with me, but it's always good as you're going through the video lesson to try some examples on your own and then follow up with my explanation of each problem. So when I'm looking at the relationship that 80 has with x, the first thing I recognize is that they're on the same parallel line. So that means they're either vertical or they're a linear pair. Since they're adjacent to each other and they form a line, I know that x is going to be a linear pair with 80, which means it's going to have to be 100 degrees. Another way I can kind of do that is go through my dot, dot, squiggle, squiggle, and understanding that a squiggle plus a dot has to add up to 180. Also, y is a, let me use my highlighter here, y is a dot, and 80 is a dot, therefore y would also have to be 80 degrees. Now I need to understand the relationship. We said x and 80 had a linear pair relationship. You can just state it just like that. And y and 180 were alternate exterior angle theorem. That's what brings them together. Okay? So let's look at numbers 5, 6, and 7 together. The line on 7 there just got a little underextended, so we're going to add that little piece to the transversal there. 5, 6, and 7, they asked me to find the value of x so that n would be parallel to m. State the theorem or postulate justifies your solution. So in this case, we want to set up the correct angle relationship so that the lines become parallel. So if I'm deciding between converse or regular theorems or postulates, here I'm going to be using the converse because I'm trying to find an angle relationship, an x value, that would make the angles either congruent or supplementary, and therefore the lines would be parallel. So it's not premature to go ahead and put in your dots and your squiggles because it's going to help you understand the relationship that you want to find. So dot, dot, squiggle, squiggle, dot, dot, squiggle, squiggle. It's a little tough to draw in there, but you can do your best. So dot, dot, squiggle, squiggle shows me that the 3x plus 48 is a squiggle, the 5x is a squiggle. So if I want these lines to be parallel, I would want 3x plus 48 to be equal to 5x. The relationship that those squiggles both have are that they're on the outside and they're on opposite sides of the transversal. Outside opposite tells me alternate exterior angle converse theorem. But now let's go ahead and solve for x to find how that's going to be equal to each other. So I'm going to subtract 3x from both sides. I'm going to go ahead and divide by 2. And I'm going to get x is equal to 24. Same thing in number 6. Let's go ahead and do our squiggles and our dots. Both my x expressions are squiggles, so I wanted to set those equal to each other. It's also important to understand the relationship that those two squiggles have with each other. In this case, this angle and this angle. If I'm using my angle relationship from last class, those would be corresponding angles. And since I'm using the converse, I'm trying to prove parallel, I'm going to say corresponding angle converse postulate. And now I'm going to go ahead and solve for x to make that expression true. Probably subtract 5x from both sides, subtract 13. Here I get a 10, here I get a 2, and x is going to be equal to 5. Number 7, here we're trying to prove parallel, saying that those angles in the correct relationship. Go ahead and do your squiggle, squiggle, dot, just to make sure you're getting to the right order that you want. And in this case, we have, use my red, haven't used red in a while. We have a squiggle, 5x minus 18, and we also have a dot, 8x minus 5. So in this case, one's a squiggle, one's a dot, which means the squiggle plus a dot have to add to 180. So I'm going to go ahead and set up that relationship, 5x minus 18 plus 8x minus 5. But for those two angles to be supplementary, what type of relationship do those two angles have? Well, they're on the same side of the transversal and they're inside. Same side inside tells me consecutive interior angle converse, because we're trying to prove parallel, converse theorem. So when I'm solving for x here, I have terms on the same side, so I'm going to add those together, 5x and 8x, which adds up to 13x. Negative 18 minus 5 adds up to a negative 23. Then I'm going to go ahead and add 23 to 180. Here I'm going to end up with a 203, and when I divide 203 by 13, I might need my calculator for this, I end up with a decimal. So rather than coming up with an approximated form of that answer, we're just going to leave it in the fraction, improper fraction of 203 over 13. Okay? So can you prove, and we're going to move on now, okay? Can you prove that lines P and Q are parallel? That's the question. If so, state the theorem or postulate that you would use. So the first thing it would be helpful to understand in these types of questions is they're asking to prove parallel, which means we're going to be using that converse idea of if the angle relationship matches one of my angle relationships, either congruent or supplementary, then I can show that they're parallel. So the first thing we need to remember in these types of problems is these arcs tell me that this angle is given and it's congruent to this angle. One angle's on line Q, one angle's on line P, and they both are on the same side of the transversal cutting through it. And if I look at them closely enough, I understand that the angle relationship between these two arcs is that angle 1, we'll call it, and angle 2 are corresponding angles. And if they're corresponding, they're both dots or they're both squiggles, and in that case they would be congruent to each other. So because they are congruent, we can state that yes, P is parallel to Q because, and we're going to have to state our reason here, because by the corresponding angle converse postulate. Example 9, they give us two new arcs. They tell me this arc on P and this arc on Q are congruent to each other, meaning angle 1 and angle 2 are congruent. And because they're alternate interior angles and they're congruent, we also can say that yes, P is parallel to Q because by the alternate interior converse, or angle converse theorem, I would know those two lines are parallel. Now, number 10 is a great non-example, and it's always included in our notes because we don't want students to get tripped up by this type of situation. Here we have an angle that's vertical and congruent, which is true. These have to be congruent angles. Angle 1 would be congruent to angle 2. However, they don't give me any markings along line P and also crossing with the transversal. So because I don't know any of these angles here off of P in the transversal, there's no relationship that I'm given to understand between the lines P and Q. So can I prove that line P and Q are parallel? No, there's not enough information. Not enough info is given. So if I wanted to go ahead and find more about line P and the relationship it had with the transversal, then maybe I'd be able to prove parallel or not, but at this point I don't have enough information to do so. So let's slide to the last page of our notes, and we're going to go ahead and go along the same type of logic of determining if I need converse or the regular theorem to prove parallel or to find the angle relationship. The first thing it says in the directions is use the figure, this figure right here, where N and M are parallel to complete the following statements. So because they give us that N and M are parallel to each other, that would tell me that squiggle squiggle dot applies, and I can label 1 and 7 as dots, 3 and 5 as dots, 4 and 6 are squiggles, and 2 and 8 would be squiggles. And remember, since the lines are parallel, dot equals dot, squiggle equals squiggle, and a dot plus a squiggle has to add to 180 degrees. So let's go ahead and first look at some of the relationships that they give us. In number 11, they said angle 4 is 20 degrees. So what would angle 7 be? Since angle 4 is a squiggle, that means angle 7 would be a dot. And because a squiggle plus a dot adds up to 180, when I take away 20 from 180, I get angle 7 to be 160 degrees. In example number 12, angle 5 is 75 degrees, and it's a dot. Angle 8 is a squiggle. These are consecutive exterior angles, and because one's a squiggle and one's a dot, they also have to be supplementary. So when I take away and find the supplement of 75, I take away 75 from 180, I end up with an angle of 105 degrees. Number 13 is a tricky question. I'm going to star that one just because it's kind of different. Here in number 13, we're given that line N is perpendicular to line T. N is perpendicular to line T. So if N and the transversal are perpendicular, that means that the angles that they form are right angles. All four angles here would be right angles, meaning all their measures would be 90 degrees. Dots would be 90 degrees, squiggles would be 90 degrees. So if that's the case, and these lines are parallel, that means 3, 4, 5, and 6, those angles would also be 90 degrees. So here I can state that the measure of angle 3 is also 90 degrees. This is one of those special cases where 90 equals 90, a dot equals a dot. This is also where a squiggle plus a dot is also supplementary because 90 plus 90 is 180. Okay? So we're going to look at a couple more examples that are a little bit more challenging. We incorporate multiple parallel lines and transversals. So this is a tough problem because of the image and trying to understand the relationships that we're looking at here. I'm going to use different highlighters to help us visualize these relationships. So in number 14 we have angle 3, which is right here in orange, and angle 10, which is right here in orange as well. So the first thing you want to do when you have these types of problems with multiple possible parallel lines is you want to identify the transversal as well as the possible parallel lines that they're looking for. So looking at angle 3 and angle 10, they don't share an intersection or a vertex, meaning that the line they do share, line P, is my transversal. Transversal P. The possible parallel lines are the two lines they don't share. So M and N are my possible parallel lines. So if I want to try to prove that they are parallel, I need to understand the relationship that 3 and 10 have with each other. So when I look at these angles, I might have a squiggle here and a squiggle here, a squiggle here and a squiggle here, and because 3 and 10 are both squiggles, then yes, I would know that M and N are parallel. M is parallel to N if those two angles are congruent. Alright? So now let's go ahead and look at number 15. Number 15, I'm going to erase some of my work in my picture here so we don't get that confused with other problems. Here in number 15, I'm going to use a green highlighter. We're looking at angle 1 and angle 14. And the first thing we want to pick up is where's the transversal? Where's the line that these two vertices share? And when I go ahead and click at the vertices, angle 1 is formed between lines M and P, and angle 14 is formed between the lines N and Q. And since there's no transversal, no line that they share, neither sets of parallel lines could be proven parallel in this case. 11 and 15 now, if we jump to the next example. 11 and 15. Here's angle 11. Here's angle 15. Let's get rid of our green highlights to help us visualize. So 11 and 15, they share a transversal of line N. So my trans is N. My parallel, or my possible parallel lines would be the lines they don't share. So that would be P and Q. And if I'm trying to prove P and Q are parallel, I need to look at their relationships. If this was a dot, then 10 would be a dot, squiggle, squiggle. Same pattern would exist. So since 15 is a dot and 11 is a dot, then I know they're congruent, and they are. Dot is congruent to dot. So that means, yes, P and Q are parallel. Okay? This is an old SOL question. We always love throwing these old SOL questions back out at you guys so you guys can kind of get practice and get ready for the test at the end of the year here in Virginia. So if lines A and B are parallel, what is the value of x? So we have to look at this direction very closely, and this is my hypothesis, and this is what's given to me. So they tell me that line A and line B are parallel to each other. So those are my parallel lines. And they want me to find the value of x. So it's important to understand the transversal that we're trying to use to find angle x. Angle x is right here. There's my vertex. And C is going to have to be my transversal because that's the angle. Angle x is formed by line C and line B. So I'm looking at the green and orange lines. What's the relationship that this angle x has with one of the other angles that's also on line C but not on line B? So that would be the 120. So when I look at 120 and I look at x, right off the bat I don't really see a relationship that those two have. But since I know that A and B are parallel, I know squiggle squiggle dot works. So I'm going to go ahead and quickly label my squiggles and my dots. And because the lines are parallel, a dot plus a squiggle has to add up to 180 degrees. So since my dot is x and my squiggle is 120, x would have to be a supplement with 120, meaning that x would have to be equal to 60 degrees. Alright, so again, if there's any point of the lesson where you were a little confused and you need to go back on, please go back and review and try the practice problems in your practice packet. Also, don't be afraid to subscribe to my YouTube channel just so you can catch up on all the new videos and updates that I make throughout the year. Alright, thanks guys. Have a great day.